Stonehenge, a circle of ancient stone standing alone on the wide, windswept plains of southern England. For centuries, it has been described as a mystery, a riddle, a relic of a forgotten world. But new high-resolution 3D scans, precise to less than half a millimeter, are revealing something far more astonishing. This monument is not a random arrangement of monoliths, nor a crude ritual site built through guesswork. It is a 4,500-year-old engineering project, a construction planned with geometry, aligned with the sun, shaped with intention, and assembled with an understanding of structural forces that still impresses modern engineers. Hidden tool marks, mathematically curved lintels, mortise-and-tenon joints carved directly into solid stone. A circular landscape boundary stretching nearly 2 kilometers wide. Everything we thought we knew about Stonehenge is being rewritten not by fantasy or myth, but by data. This video takes you inside that data, inside the stones, the landscape, and the minds of the people who built one of humanity's most enduring structures. Stonehenge is not just a monument. It is a blueprint written in stone for a civilization that understood far more than we ever imagined. Seen from above, Stonehenge becomes something completely different from the scattered ruins we imagine. It reveals itself as a precise architectural plan, a deliberate composition of circles, alignments, and interlocking forms. The outermost feature is the Sarsen circle. 30 massive upright stones, each originally standing around 7 meters tall, linked together by horizontal blocks called lintels. These lintels form a continuous ring about 30 meters in diameter, shaped in a gentle but accurate curve. Inside that circle sits another arrangement, the bluestone oval, made of smaller, darker stones transported from over 200 kilometers away in Wales. And at the heart of it all stands the most dramatic structure, the Great Trilithon Horseshoe. This sequence of 5 gigantic stone doorways, each made of 2 uprights, topped by a single lintel, opens toward the northeast like an ancient cinematic frame. This orientation is no accident. The center of the monument's axis points directly toward the place on the horizon where the sun rises on the summer solstice. Turn 180 degrees, and the same axis aligns perfectly with the winter solstice sunset. This dual alignment suggests a sophisticated understanding of the solar cycle, woven into the very geometry of the monument. The spacing of the stones, the diameters of the circles, and the height of the lintels all reinforce the same structured design. Even the earthwork bank and ditch surrounding Stonehenge, built centuries earlier, forms a giant circular boundary, enclosing the stone settings like the outer wall of a temple complex. Approaching from the northeast, visitors walk along a formal avenue, 2 parallel banks guiding movement toward the entrance. This engineered corridor frames the rising midsummer sun as if Stonehenge were a massive astronomical instrument designed to catch a single moment of light. Standing among the stones, the scale becomes overwhelming. The tallest trilithon rises above 7 meters, and the lintel ring forms a remarkably level horizon line, even though the ground beneath it slopes noticeably. Every element from alignment to proportion reveals a blueprint executed with intention. Stonehenge was not improvised. It was not guessed. It was designed. No written records describe who built Stonehenge or why, but the soil beneath and around the monument contains the answers. Archaeologists have uncovered layers of settlement remains at Durrington Walls, located just a short walk from Stonehenge. Here, they found animal bones, broken pottery, pieces of wooden houses, and charcoal everyday debris from a thriving community. Crucially, these remains can be dated precisely using radiocarbon analysis. Again and again, the results cluster around 2500 BCE. This period lines up perfectly with the construction of the giant Sarsen stones, meaning the people living at Durrington Walls were almost certainly the builders of Stonehenge. The timeline of construction emerges in clear phases. First came the circular ditch and bank, then timber posts. Finally, the monumental arrangement of Sarsen and bluestones that defines the Stonehenge we recognize today. The radiocarbon dates from the ditch, the stone holes, and the settlement debris all overlap, showing the main stone phase was built over only a few generations, not centuries, of gradual expansion. This makes Stonehenge the result of a concentrated, coordinated effort by a single cultural group. And yet, these Neolithic builders did not have metal tools. They had no wheels, no draft animals to pull heavy loads. Their toolkit consisted of stone hammers, wooden levers, antler picks, and ropes made from plant fibers. Despite this, they cut mortises into rock, shaped curved lintels, transported stones weighing up to 30 tons, and aligned the entire monument with solar events. There is no evidence of outside intervention, no strange artifacts, no advanced technology, No cultural intrusion from later civilizations. Everything dates firmly to the late Neolithic, and every trace in the soil matches the same time frame. The earth itself testifies. Stonehenge was built by the farmers, craftsmen, and families who lived on this landscape 4,500 years ago. We often imagine Stonehenge as an unchanging relic, but its shape has shifted dramatically over the last century. Stones have fallen, cracked, tilted, and been raised again not by ancient builders, but by modern hands. In the winter of 1900, one of the great trilithons collapsed. An upright snapped at its base, the lintel shattered when it hit the ground, and another supporting stone leaned dangerously as if preparing to fall. Photographs from the era show a monument in distress gaps in the Sarsen circle, tilted uprights, and broken lintels scattered on the grass. Alarmed by the decline, Sir Edmund Antrobus initiated the first major restoration effort in 1901. Workers dug around the unstable stones, propped them up with timber, and poured concrete into newly excavated pits to stabilize their bases. Winches and timber frames hauled stones upright, marking the first time in centuries that humans had physically re-erected parts of Stonehenge. This set a precedent. Concrete footings, steel pins, and rigid anchors began appearing under stone after stone as conservators prioritized stability above authenticity. After the First World War, restoration accelerated. From 1919 to 1920, more stones were straightened or lifted. Workers drilled deep holes into the sarsens to insert steel rods, securing cracked or leaning uprights. Steam-powered winches and cranes replaced manpower, lifting multi-ton stones into place. By the late 1950 seconds and early 1960 seconds, with tourism booming, the Ministry of Works carried out the most ambitious overhaul yet. Cranes swung massive lintels through the air, fresh concrete was poured around bases, and several stones were repositioned to restore what archaeologists believed was the monument's original geometry. The process was dramatic and sometimes destructive. Portland cement, chosen for its strength, trapped moisture inside the porous Sarsen stone, accelerating weathering and fostering new cracks. Hidden steel pins rusted and expanded, exerting internal pressure that risked splitting the stones from within. By the 21st century, these problems became impossible to ignore. Beginning in 2021, English Heritage initiated a new phase of conservation, removing failing concrete, extracting corroded steel, and packing joints with lime mortar, a breathable material that protects without sealing moisture inside. Today, Stonehenge stands as a hybrid. Ancient engineering above ground, 20th century interventions below, and careful modern conservation ensuring that the monument survives without being suffocated by its own repairs. Look closely at the stones, especially under angled sunlight, and the work of Neolithic craftsmen becomes unmistakable. The surfaces facing the avenue, the sunrise, or the interior of the circle show a level of finishing approaching polish. These areas are subtly smooth, with shallow ripples left by countless blows from stone hammers. The effect is deliberate, not accidental. The builders shaped these faces to be seen. In contrast, the backs of the stones, those facing outward or buried in the ground, were left notably rougher. Large flakes, deeper percussion marks, and coarser textures dominate these unseen sides. This dichotomy tells us something profound. The builders cared deeply about visibility. They controlled what visitors saw as they approached, where their eyes were drawn, and how the monument would appear during key solar events. Microscopic analysis of tool marks captured by modern 3D scans reveals a clear sequence of shaping. First, rough reduction with large hammerstones, then medium-scale pitting to even the surface. Finally, fine pecking to achieve a subtle sheet. These differences are not random but consistent across the monument, especially on the tallest trilithons and prominent Sarsen uprights.
In high
the
fidelity.
finishing reflects both aesthetic intention and cultural meaning. Stonehenge was not just built, it was crafted. Stonehenge's durability is often attributed to the sheer size of its stones, but weight alone does not explain why so many uprights and lintels remain standing after 4,500 years. The builders engineered a structural system as intelligent as it was monumental. Each upright sarsen was placed in a pit wider and deeper than the stone itself. One side of the pit was cut at a slope, enabling the stone to be tipped upright from a horizontal position, likely using wooden sledges, ropes, and teams of laborers. Once in place, the hole was packed tightly with chalk, rubble, and smaller stones. This created a solid foundation that distributed load evenly and resisted lateral movement. But the true brilliance lies in the connections above ground. Mortise-and-tenon joints. On top of the uprights, the builders carved rounded protrusions, the tenons. Under each lintel, they carved matching mortise sockets. When lowered into place, the lintel locked onto the upright like a giant stone woodworking joint. Laser scans show that many of these joints fit with tolerances of less than a centimeter. Tongue-and-groove lintel connections. The lintels are not simply resting on the uprights. Along their ends, they include horizontal tongue-and-groove joints linking each block to its neighbor. This transforms the lintel ring into a continuous load-bearing frame, preventing individual stones from twisting or slipping. Curved and leveled lintels. The lintels were shaped to follow the arc of the circle, and their undersides were carved so that the tops of the ring remain almost perfectly level, even though the ground slopes beneath them. This required repeated measurement, careful shaping, and an understanding of geometry. Structural performance. Modern engineering assessments show that these joints continue to function well. Loads are distributed correctly, and the structure still resists wind and seasonal ground movement much as the builders intended. Far from being a crude arrangement of rocks, Stonehenge is a locked, integrated system, engineered with an understanding of material behavior, weight distribution, and long-term stability. In 2011, a team from the Green Hatch Group undertook one of the most ambitious digital recording projects ever attempted on an archaeological site. Their goal: to capture every visible surface of Stonehenge with extraordinary precision. Using phase-based and pulse-based laser scanners, the team documented the monument at a resolution of roughly 0.5 millimeters, enough to detect the faintest tool marks and the shallowest surface irregularities. Over several weeks, they worked outside public hours, weaving equipment between the stones and raising camera booms up to 12 meters high to capture the tops of the lintels. The resulting dataset exceeded 800 gigabytes, forming a digital model of breathtaking detail. The scans revealed patterns invisible to the naked eye. On Stone 53, researchers detected 2 Bronze Age axe carvings so eroded that they had been overlooked for centuries. Surface textures showed varying densities of small percussion marks, allowing analysts to distinguish between rough shaping and fine finishing. The scans also exposed scars from later eras. 18th century graffiti, mortar repairs from the 20th century, and subtle cracks forming due to old restoration work. This forensic detail provides conservators with a precise map of weathering and structural stress, enabling proactive preservation. But the scans do more than document damage, they quantify Stonehenge's engineering. Measurements extracted from millions of data points show lintel curvatures deviating by only centimeters across the entire ring. Tenons and mortises align with remarkable accuracy. Surface deviations across large spans remain within millimeters. These findings confirm that the builders did not rely on guesswork. They shaped these stones repeatedly, testing and adjusting until the pieces fit not roughly, but with a precision that stands up to modern scrutiny. The digital model captures Stonehenge not as a ruin, but as a complete engineering system, freezing every joint, fracture, and tool mark in time so researchers can continue exploring the monument in unprecedented detail. In 2020, geochemists used portable X-ray fluorescence devices to analyze the chemical signatures of the standing Sarsen stones. To their surprise and excitement, 50 out of 52 stones matched almost perfectly with sandstone found in West Woods, a forested area roughly 25 kilometers north of Stonehenge. This means the builders did not gather random boulders scattered across the landscape. They selected a specific quarry site with consistent material qualities. This choice allowed them to create joints and lintels that fit predictably, because the stones shared similar hardness, grain structure, and durability. Transporting these enormous blocks, each weighing between 20 and 30 tons, was a logistical achievement on a monumental scale. Without wheels or draft animals, teams likely dragged the stones on wooden sledges along routes cleared through forest and over rolling hills. Experiments suggest that hundreds of people pulling in coordinated rhythm could move a stone several kilometers per day, especially if the sledges were lubricated with water, mud, or animal fat. The journey from West Woods to Salisbury Plain crosses streams, ridges, and uneven terrain. Organizing labor, providing food, planning stops, and maintaining equipment would have required a level of social coordination that speaks to a highly organized community. Once delivered, the Sarsens were trimmed, shaped, and fitted into the architectural plan with astonishing precision. The geochemical fingerprint preserved in the stones forms a direct physical record of a Neolithic supply chain, one of the largest and best documented in prehistoric Europe. Stonehenge does not stand alone. In 2020, a team led by Professor Vince Gaffney used ground-penetrating radar and electromagnetic sensors to scan the fields north of the site. What they found shocked everyone. Beneath the quiet grasslands lay a ring of more than 20 huge shafts, each about 10 meters wide and up to 5 meters deep. Together, they form a circle nearly 2 kilometers in diameter, enclosing the settlement at Durrington Walls. This was not a collection of random pits. The spacing is consistent, the measurements deliberate, and the placement remarkably accurate given the rolling terrain. Radiocarbon dating of antler and bone fragments found within the shafts places their construction around the same time as the main Sarsen phase of Stonehenge, around 2500 BCE. This means the same communities that raised the stone circle engineered a massive boundary system across the landscape. It may have guided ceremonial processions, defined sacred space, or marked a zone restricted to certain groups. The sheer scale of this landscape design implies sophisticated surveying methods. Without written numbers, metal tools, or surveying instruments, Neolithic builders may have used ropes of fixed length, horizon markers, and repeated sighting checks to pace out distances across vast areas. The shaft circle transforms our understanding of Stonehenge. It was not a solitary monument, but the centerpiece of a vast, planned ceremonial complex. One of the most compelling aspects of modern Stonehenge research is how different scientific disciplines, each working independently, arrive at the same conclusions. Laser scans reveal precise geometry and intentional finishing. Geochemical analysis traces the stones back to West Woods. Radiocarbon dating at Durrington Walls and within Stonehenge's construction trenches anchors the timeline around 2500 BCE. Ground-penetrating radar uncovers the giant shaft circle, confirming large-scale landscape planning. Each method stands on its own, but together they form a powerful, interlocking body of evidence. They show that the stones came from known prehistoric quarries. The builders used stone and wooden tools. The monument was built within a specific, well-documented time frame. The construction techniques were sophisticated, but entirely achievable with Neolithic technology. There is no scientific need to invoke lost civilizations, supernatural powers, or extraterrestrial help. The engineering is visible in the joints, the measurements, and the materials. The planning appears in the alignments and the landscape features. The timeline is written in the soil. Stonehenge is a triumph of human ingenuity, nothing more mysterious than thousands of skilled hands, coordinated vision, and generations of cultural tradition. Despite everything we know, Stonehenge still keeps some secrets. How exactly were the massive lintels lifted and placed with such accuracy? Were earthen ramps used, or timber A-frames with counterweights? What surveying methods allowed Neolithic builders to mark out a nearly perfect 2-kilometer circle across uneven terrain? Even bigger questions remain about purpose. Was Stonehenge a ritual stage, a solar calendar, a monument to ancestors, or a gathering place connecting distant communities? The polished faces, the controlled sightlines, and the surrounding landscape all point to layered meanings, social, spiritual, and political. We may never discover the full story, and perhaps that lingering mystery is part of what makes Stonehenge so compelling. Modern technology allows us to see Stonehenge as its builders intended, not as ruins, but as a complete, functioning structure. Laser scans reveal the precision. Geochemistry reveals the supply chain. Radiocarbon dates reveal the timeline. Landscape surveys reveal the larger design. Stonehenge stands today not because of magic or myth, but because its builders designed it intelligently, deliberately, and with an ambition that still echoes across the plains. It is a monument to human skill, community, and imagination, written in stone, preserved by science, and still challenging us to understand it fully.